Good morning, good afternoon, anyone who's watching this, wherever you may be. Good luck on this. I'm gonna try making this a sweet and simple one. Just know we're kind of talking about agriculture, continuing, and really kind of speaking on meat production, especially in this one, because as we're gonna find out, meat production is quite intensive when it comes to the resources needed to produce them. And we're going to kind of talk about the 10% rule of why that is, or entropy. And we've discussed that in the past, but we'll kind of go into it more detail in this lecture. So follow along, have fun, and hopefully you don't find me too boring today. All right. Great video. Going to start you out with. I really recommend the video, "The Hidden Cost of Hamburgers." Absolutely essential. It's on YouTube, but it really kind of puts into perspective and puts the numbers behind beef production. But just know it's usually meat production, and we're going to talk about why it is the way it is, right? And kind of talking about entropy, why a kilogram of rice or a kilogram of wheat is less intensive on the environment than a kilogram of beef or pork or chicken. So kind of starting this one out, I don't, this sometimes gets into kind of, gets into a conflict discussing, turning to vegetarianism or veganism. So I'm not advocating for either or, right? I just want to really stress that you do you, right? But we also have to do you in an environmentally conscious way. Everything we do, we need to start thinking environmentally, right? And the biggest aspect of that, the most, we're taking out the whole idea about the morals behind eating less meat, animal cruelty. We're not going to talk about that today. We're not going to talk about the health issues associated with, eating more of a vegetable-based diet versus a meat diet, right? But we are going to definitely talk about the environmental implications of that, and hopefully, once again, not advocating for, I guess the main goal is knowing that we have to change our agriculture, whatever that might be in the future, and we can talk about those things in class. But maybe getting you to eat a little less meat and maybe a little bit more vegetables or grains not only helps the environment, may make you more healthy. I'm not a doctor. And maybe it'll be a little bit more kinder to animals because I'm sure they don't want to get, chopped up. But besides that, I'm not going to advocate for it. I do, though, as an environmental science teacher, to kind of give you a little background, I grew up on a farm. We had my uncles own this intensive corporate kind of farming, and I've probably stayed that before. And I grew up surrounded by cows going in and out of the slaughterhouse, not really going in there and seeing what's going on. So I grew up with it, right? That being said, as now an environmental scientist, I am rethinking that lifestyle, or at least a part of it, or cutting it back. As an environmental scientist, just to put my foot where my mouth is, or is that the right? No, that's the wrong saying. But to put my money. There's an analogy I'm looking up for, but I guess to kind of to practice what I preach. There we go. I found one. All right, to practice what I preach. I've definitely cut down my meat consumption. I actually don't because beef and pork are the two most intensive on the environment. I've completely cut them out of my diet, and for health reasons as well, right? And be nice to the animals. I do eat chicken from time to time, just due to the protein. Even though you can still get quite a bit adequate amount of protein from vegetable sources, sometimes I'm really going for a lot. But anyway, I've definitely cut back, and maybe you can think about at least cutting down on one meal per week, if not per day, or going, something along those lines. All right, so watch that video. It's a good one. It's more factual based, though. It really talks about, the statistics behind where you get your hamburgers and what constitutes your hamburger. So I would highly recommend watching that before you go on this lecture, because then it gets you this idea in your head. All right, moving right along, though. With that, there we go. And another one. This one's definitely, I kind of put these at the beginning because there's stuff to think about, right? You definitely need to think about these issues, the price of a hamburger environmentally, as well as, starvation. Keep those on your mind. So in your workbooks, as you'll see, there is a discussion on Yemen underneath there. I think it's somewhere in the middle, so apologies if it's down there a little bit, but there is, hint, hint, something in your workbook to be written on that one. Okay, this slide right here, look, I'm getting a lot of things out of the way. This you're actually going to be doing in group work. You're going to be discussing the social, economic, cultural, ecological, political, and economic factors can be seen influencing our choice of food production systems. You're going to be talking about this in group and coming up brainstorming with how those things affect your eating habits. And we'll discuss that later. All right, now kind of on to the actual lecture itself. We're starting out with a couple graphs, but graphs are obviously huge, important to IB. Your test will just have many of these, and you have to understand them. So take a look at this graph. What does it mean to you? Pause me if you could. But this is really what this is saying is arable land needed to produce a fixed quantity of crop products, all right, since 1961. So really what this graph is showing you is that starting off here at the very top, it required this much land to produce this much food, right? Let's just say, I don't know if it says it on here, I can't really see, but let's say a kilogram. Well, it needed that much space. Well, it's slowly going down, right? We see this graph going down. That means it's needing less and less space to produce the same amount of food. Congratulations, we're done. We've solved all of our problems. No, we haven't. As you're going to see, there's another problem. So this is great. We're using less land per, like, let's say kilogram or amount of grain crop, but there are some problems which a modern society we are now getting into, which is this. Arable land per capita per person. We are just getting too many people on this planet. So even though we are using less and less land per quantity of food, it just cannot keep up because we have so much people. So we have to now take over rainforest. We now have to take over, Sahara or desert regions and try growing crops them because we just have so much more people that we have on this planet. And it just shows you developed countries need way more intensive than developing countries as well. So we go to the 10% rule. That is the reason why we are having this issue. Remember back to entropy. Every step up on the food chain, you lose 10% or you lose 90%. Roughly, only 10% travels to the next food chain. So to kind of remind you, almost all 100% of our energy comes from the sun. At least when we're talking about environmental science, right? All of that energy, 100% goes down to land. Well, the plant absorbs that, right? Gets that 100%. Well, when a zebra, I think that was the picture we used. Remember, the zebra comes along and eats that plant. Well, it only takes, now that, if let's say it eats the whole plant, so it takes the 100%, but 90% of that is lost due to respiration. This is kind of a recap for you, right? Respiration, so only 10% goes on to the zebra. Well, then the lion comes along and eats the zebra. Well, now what was 10% is only now 1% because through each step, it's losing 90% of the energy, right? We have to remember that. That is entropy, and that is key to understanding why a burger is so much worse for the environment than let's say, a kilogram of grain, right? So let's think about it this way. You have a wheat crop that grows. You could simply take from that wheat crop and eat a kilogram of that wheat crop. Well, you're pretty much taking that and you're getting, 90% of it is being lost because you're eating it right away, but you're absorbing 10. But now instead, let's say you're going to eat beef and you're making a burger out of it, right? So there's the wheat crop. Then you have the cow that comes along and eats that. So then only 10% goes on the cow. Then you're eating a kilogram of beef. Let's say you're only getting 1% of the overall energy production, right? This is key to understanding. And it is not that simple as well. Think about a burger. It's not nearly that simple, right? A burger not only has beef in it, but then it has the bread, which you think, well, that's a grain, Chase, isn't that good? No, because it goes through the process of turning it into bread. When you take grain, then think about all the energy required to ship it to grind it up, to go through the production system, to bake it, to break that bread. It goes through way more steps of energy use. So that is why a burger just takes so much more energy than just even a kilogram of grain or even a kilogram of beef. A burger will take so much more energy to go through. Very summed up, but I hope you kind of go through that when we were discussing entropy in the past. Just know each of those steps requires so much more energy. And not only that, but think about, a McDonald's burger, for example, right? It's going through the whole process of maybe getting shipped around the world. That takes energy. All the people that it takes to, put that burger together. In a way, they are using energy too, because they ate some food and then they're putting that energy towards making a burger for you. It's so much more intensive. There's so many more steps in regards to a burger rather than just throwing some rice on the saucepan, boiling it for a while, and then eating it, right? Even rice, though, we have to say, even if you're buying bagged rice, right? It's not like you're taking it from the rice field. Then it has to be transported, loss of energy there. Then it has to be cleaned, loss of energy there. Then it has to be bagged, which you're using energy there. So even a kilogram of rice isn't directly like just a kilogram of rice from the field, right? That's why hunting and gathering societies were so much more better for the environment. They simply are directly taking their energy in this one step, put in your mouth, right? Or even, hunting, then you take that meat, cook it, so there's a little bit of loss of energy there, but it's much fewer steps, a lot less energy loss, right? Eating lower on the food chain, one or more of the following benefits would be likely. Not as much land, right? That just goes back to land. If you are eating directly from the land, you need an acre of food to sustain you. If you're going to eat a cow, well, that cow needs an acre, right? Or actually, that cow probably needs way more than an acre of food because it's a much bigger animal. So you actually have to produce way more land just to eat that one cow. Then that's just one cow. How long is that going to last you before you move on to the next cow, right? That's why it's so much more intensive. Overgrazing in public and private rangelands would decrease, would not have to farm or graze marginal lands as intensely. More people in the world could receive an adequate diet. Less fossil fuel energy and associated emissions of CO2 would be required, or less energy would definitely be required, right? So, and then it just kind of talks about the differences between terrestrial versus aquatic as well. I'm bringing that down. But it's important to understand if we were to change if everybody was to go vegan, and once again, not advocating for it, I'm just simply stating facts here. If everybody was to go vegan, we would need probably less than 1/4 of the agricultural land we need now. There's actually a great graph in AP Environmental Science. I need to find it for you guys. That really breaks. It has like the United States, but it breaks down to how much land is just used to feed our food, if that makes sense. It's insane. It's 50% of the United States goes to just feeding our cows and pigs and sheep. So if you can think about that, if we got rid of just not eating cows and beef, beef, chicken, and pork, we could really save, all that land could go back to biodiversity or, other resources that we could utilize, right? So it's important to understand these concepts. And, kind of going on, with that before I go on to this slide, it's key to remember that, there's all these steps. It's important to remember that energy use or production of food or your things goes through intensive processes. And it's not usually, you're thinking of a burger, you're just thinking of simply of the beef, maybe the grain, maybe the onion or the tomato in it, if you like that, right? But you're thinking of just those ingredients. Just remember, each of those ingredients goes through so much processing, so much energy use just for, just the onions in your burger probably take, use tons of carbon emissions, right? Just because it takes it, you have in the farmer grab it, you have the truck that takes it, you have something that washes it, you have something that transports it to where you are. It's an intensive process, right? So keep that in mind when we're going through this. Primary economic activity. This is just thinking about farming and agriculture in a system unit. You're actually going to be having a group work on this next week, talking about these inputs, outputs, and processes. So I'm not going to speak on it too much because I'm going to kind of have you do the brainstorming on what is the difference between MEDC or a more developed country versus a lower developed country, and how their agriculture changes and how the system look of their agriculture would change as well. Okay, I know this is a part in your workbook, but I'm not going to stop and go through all these. These are for you. I want you to go through these and understand them. It's pretty much vocabulary, and I'm pretty much giving you the answers to your workbook right here. But go through them, understand them, so when I do talk about slash and burning, you know what we're talking about. These are essential vocabulary for your IB. All right, not gonna this is more what you can do to kind of read up on it, right? So talking about systems and farming as a system flow chart, so we'll kind of talk about these, right? But when we're this one's kind of giving you answers in your group work, but no, this is good because this will help you out in your group work because I think I require a little bit more. But just think about the inputs to farming, right? You need a lot of stuff, and even this is a very, very simplistic system diagram. But you need rainfall, you need water, length of growing season, you need time, right? You need temperature, you need relief, soil, drainage, you need human labor, you have rent, maybe transportation costs. I could go on and on. Growing up in this environment, there's so many inputs to make a running farm, to make even a agricultural field run. You need so many inputs. Then going on to processes, right? You have plowing, you have weeding, watering, harvesting, milking, fertilizing, pest control, grazing, on and on and on. Those are the big ones. Then there could be possible changes to the system, right? Some could happen to your food. You could have a hailstorm, or you could have too much rain and it kills your crops, right? Human demands might change, right? Maybe they don't want your given crop anymore, or they want more of it. So those are things to think about. Then outputs are your actual product that you ship out, right? Which are mainly crops and animal products, but think about, this should kind of, while you're thinking about this, think about the lower economic developed countries. What are the outputs there? When you have a farm, think about the farm agricultural system setup, right? I've told you about American and Western cultures, and even in Thailand, there's slowly changing to this, but you have these big corporations who are in charge of these agricultures, right? Like now my family, I remember growing up when I was a kid, it was kind of a family thing. Now it's this big corporate thing, right? So think about what's the differences, right? What's the differences between a poor, Thai farmer up north who's growing rice for his family, maybe selling a little bit on the side at the market, versus a corporate agricultural unit? And the outputs are definitely much different, and the inputs are probably different as well, and maybe the processes as well. And this kind of goes into this. Like I said, I'm not going to spend too much time on this because you are actually going to do group work on this next week, but just kind of to get you an idea, right? There's terrestrial farming versus or subsistence farming versus commercial farming. Those are the two big ones. We have commercial, which is the big corporate; subsistence farming, which is you're making enough to sell, to eat, as well to sell to family, friends, maybe local market. Both commercial and subsistence can be intensive, right? They both are. Let's just be real about it. Intensive on the nature, or come at environmental impact. Intensive farms take a small area of land for high input. Extensive farms, large in comparison to the money and labor put into it. So just kind of know those differences. Once again, think about the differences in these two type of farming systems. And this is going to kind of help guide you as well, right? But sorry, not to peek in here too much, but the purpose is the labor force, the machinery, the farm. I can't even see that because it's in yellow. The farm size, they're all going to be quite a bit different. So look at this when you're kind of thinking about this in group terms. But Obviously, when we're talking about subsistence agriculture, it's going to be much lower scale. You're probably going to use less machinery. You're not going to sell very much, or at least it's not going to go really on the market, let's say. Where a corporate farm, you're going to have a lot of employees. You're going to have these high-tech machinery. You might be selling quite a bit extensively of this stuff, right? So it's kind of important to know the differences between them, all right? And then I believe, well, yeah, okay. Try to make this quick for you. Already 20 minutes, but just know then we're going to kind of talk about in the next one, but desert and desertification. You know, overuse of the land. And this goes back to, now it's kind of rounding back out to our kind of 5.1, but talking about soil. We are just exhausting the land, and that's really what we're doing. We either through overgrazing, we have animals that come and eat everything, the cows, and then they trample everything and it kills everything, right? So they're overusing because we need to fit so much cows on a given land as much as we can to make profit. Well, there's just too much cows on the land, so or sheep or whatever, and they eat everything up, and then it leaves no seeds, leaves nothing, and then really you just have this barren land that eventually this beautiful soil gets washed away, or there's no more nutrients in it, right? And this is called desertification. Just overgrazing. But also I would like to say, you know, I think IB kind of overlooks this, but do know that's just not, desertification is not caused just by overgrazing. A big key point to this as well is farming, in simple farming. So let's say, okay, so picture this. We're growing corn, right? Now, corn needs a lot of nutrients and needs a lot of water, right? So you cut down that beautiful forest or whatever was there first. You grow corn. And let's take a step back, right? Let's look at what used to be there, maybe a forest or like a nice prairie grassland. Well, when that grass or trees died, where did the stuff go? Down. It died, decomposed, and went into the soil. So the nutrients were in the cycle. Good. Now, 2, you cut that all down, get rid of it. You're an entrepreneur. You want to have your beautiful farm, right? Well, you start growing corn, which takes a lot of nutrients, takes a lot of water. Well, if you let that corn there grow and then die, well, then some of those nutrients would go back in the soil. But is that what we do? No, right? We cut that corn down, we take it, we ship it, and we consume it. And then eventually, or, you know, we either eat it or like the corn stalks get fed to the cows. Well, you know what? We don't go and crap. You know, really what it gets down to is when you poo, right? It doesn't go back to the soil. It doesn't go back to the land. And, you know, it goes in the sewage system and out to the ocean. That's where our sewage goes. So really, we're flushing away all of our nutrients. We're not letting it go back into this cycle of regrowth and dying and then regrowth and dying. We chop it down, take it away somewhere else, and all those good nutrients end up going to the ocean, which then we're going to get to when we get to water pollution, causes eutrophication because they get too much nutrients, and then we'll find out when you get too much nutrients how that's a bad thing. So keeping this ball rolling in your head, okay? And we'll kind of talk about this in 5.3. Thank you, ladies and gentlemen. I hope you enjoyed it. Obviously, let me know if you have any questions. But some of these, you know, some of the things that we've kind of glossed over, I'm going to have you talk with classmates and work them out there. All right? So enjoy. Get ready for that. Thank you.